In engineering analysis, a structure is either classified as static or otherwise, or determinate or indeterminate. A structure is classified as either being determinate or indeterminate. Now, a structure is said to be determinate if the unknown forces acting on the structure is equal to the equations of static equilibrium. If the unknown forces acting on the structure equals the equation of static equilibrium, that structure will be said to be a determinate structure, implying that the unknown reactions can be determined by basic principles of statics. An example of a static structure is a cantilever support. An example of a supporting system, rather, is a cantilever support. We are going to look at an application or a typical example of a cantilever support. Now, in a cantilever support or an enhanced support, the support is restrained against vertical movements, and that's why we have a vertical reaction. It is restrained against horizontal movements, and you have a horizontal reaction. It is further restrained against rotation, and we have a moment acting at that support. Recently, or rather today, I was analyzing a support system for a client in a process plant. Let's take a look at what we just did today. Now, this cantilever, if you look at this section A, if you look at section A, this is section A. This is a cantilever support that is clamped onto the bottom flange of an I section. Now, the description of this drawing for construction indicates that we have 6 number of an M12 by 120 millimeter long grade 4.6 fully threaded bolt, complete with 2 nuts and its washers. Now, the owner of this facility was concerned about the design, asking if the cantilever is satisfactory against failure of the structure, the tray it is carrying. Now, this cantilever is carrying a tray all around this location, and is supposed to be supported at 1.44 meters. Now, this is a typical example of a cantilever support, but the client has a concern, asking that we extend the cantilever to the end of the flange for stability of the support. Now, the client is of the opinion that this will improve the stability of this cantilever, and doubts if clamping on only one side of the cantilever would show or will prove that this bolt would not fail. Now, we have to respond by indicating or carrying out a structural analysis. We responded by saying that the clamp support is very satisfactory considering the spacing of the cantilever. Now, we added life to this explanation by carrying out a structural analysis. Now, in the structural analysis, the cantilevers were modeled, and the various loads acting on the cantilever was translated to a free body diagram. Now, we had the weight of these cable trays calculated and applied on the cantilever, as well as the self weight of the cantilever itself, which is this. Now, after the weight estimation, the cantilever was analyzed to determine the reactions FV, FH, and the moment at the end restraints. Now, this moment was obtained as 0.145, and the vertical force obtained as 0.286. After obtaining the moment and vertical force, the next thing is to determine the free body diagram of the action of forces on the bolts. Now, when we sum moment about the eccentricity of the bolt to the end of the cantilever, we will obtain the tensile force the bolt is subjected to. After obtaining this tensile force, we obtain the additional tensile force the bolt is subjected to as a result of the reaction at the supports. Now, this is the tensile force on the bolt due to the moment applied, and that is the tensile force on the bolt due to the reaction force. The total force on the bolt was calculated as 2.23 kilonewtons. Now, in accordance to the British Standard Code of Practice for a grade 4.6 bolt, the tensile capacity was computed as 16.2 kilonewtons. And since 16.2 kilonewtons is greater than the force on the bolt, 2.226 kilonewtons, it implies that the structural arrangement under consideration is satisfactory. So that implies that this structural arrangement is satisfactory and wouldn't cause failure of the cantilever. So this is a typical example of a cantilever support. Now we have a roller support. For roller support, in a roller support system, the structure is restrained against movement in the vertical direction only. The support is restrained against movement in the vertical direction only. Now let's look at typical examples of roller supports. Now this is the diagrammatic representation of a roller support. Now we have designed structural and installed compressor systems using roller support. Let's look at a typical example from a live previous project. Now on this project, this is a compressor and these are the skid beams of the compressor. This compressor is supported on grillages. Beneath this compressor is going to be installed roller supports for the purpose of installation. This is the bottom view of the compressor. These are pad plates. These pad plates would take rollers. These rollers will be used to skid this compressor into its position during installation. Now, before these rollers were selected, we had to analyze and design this compressor skid for both static and dynamic impacts during installation. Now, this is the compressor skid, that is the trunnions. That is the base plates. These are the representation of the rollers we intend to use for analysis. At the completion of the analysis, we selected appropriate rollers for the compressors. Now these rollers will be installed at the bottom plates of the compressor. To analyze this beam, you have to incorporate all the loads coming from the compressor, the dead loads, the weight of the gear, the weight of the piping, the weight of the pumps, the weight of the turbine drivers, the shutdown and startup machine unbalanced loads that will be transmitted to the pad plates. These are the loads other consideration used in the design of these roller skates. This is the manufacturer drawing of the rollers. Now these rollers can move in this direction, and that's why we have no reaction. It cannot move in the vertical direction. That is why in a roller support it has a vertical restraint.
Right. Thank you very much for your time. Always follow us on this link, on this channel. We will be providing more information on various structural engineering design. Thank you.